In today's video, we learn about homogeneous functions. A function of two variables, f of xy, is said to be homogeneous of degree n if there exists a constant n such that f of lambda x lambda y is equal to lambda exponent n f of xy for all lambda x and y for which both sides are defined. This simply means that if f of lambda x lambda y can be written as lambda exponent n times f of xy, then the function is said to be a homogeneous function of degree n. With our first question, we have to verify if f of xy is a homogeneous function and f of xy is defined to be x plus y on x squared y squared. Our first step is to compute f of lambda x lambda y. And so here, our new x is now given as lambda x and our new y is given as lambda y. So if we see any x in this expression, we are going to substitute in lambda x. And if we see any y in this expression, we are going to substitute in lambda y. And so we are going to have lambda x plus lambda y divided by lambda x all squared, then lambda y all squared. Now let's simplify the denominator. So that's we're going to have lambda x plus lambda y divided by. So now from indices, if we have a, b, all exponents n, this is the same as a exponent n, b exponent n, right? So in the same way, we are going to have our denominator to be lambda squared x squared plus lambda squared y squared. From the numerator, we can factor out lambda. Factoring out lambda gives lambda out x plus y. And also from the denominator, we can factor out lambda squared. And so that's, we are going to have lambda squared out x squared plus y squared. This lambda will cancel out one of these lambdas. And so we are going to have 1 on lambda, then multiplying x plus y divided by x squared plus y squared. We can see that x plus y divided by x squared plus y squared is our given function f of xy. And so we are going to rewrite this guy as 1 on lambda, then f of xy, which is the same as writing lambda exponent minus 1 f of xy. Hence, f of lambda x lambda y is equal to lambda exponent minus 1 f of xy. Thus, f of xy is homogeneous of degree minus 1. With our second question, we have to verify if f of xy is a homogeneous function and f of xy is defined to be e exponent y on x plus sine of y on x. We compute f of lambda x lambda y, and so that's going to give us e. So our new x is now lambda x and our new y is now lambda y. So in place of y, we are going to write lambda y, and in place of x, we are going to write lambda x. So that's, we are going to have lambda y on lambda x plus sine of, so we have y here, this y is now lambda y, and this x is now lambda x. And so that's, we are going to have lambda y on lambda x. So now for the exponential function part, this lambda will cancel out this lambda. And also for the trig side, this lambda will also cancel out this lambda. And so at the end, we are going to have e y on x plus sine of y on x. So this is the same as writing lambda exponent 0, then e y on x plus sine of y on x. This is equal to lambda exponent 0 f of xy. Thus, f of xy is a homogeneous function of degree 0. Our third question, we have to verify whether f of xy is a homogeneous function, and f of xy is defined to be the square root of x squared plus y squared. So we compute lambda x lambda y, and so we are going to have the square root of lambda x all squared plus lambda y all squared. So simplifying this using the roots of indices gives lambda squared x squared plus lambda squared y squared. And so we can factor out lambda squared, so that's we're going to have lambda squared out x squared plus y squared. From sets, if we have square root of ab, this is the same as writing square root of a times square root of b, right? So we are going to apply the same idea here, and so we can rewrite this as square root of lambda squared times square root of x squared plus y squared. The square root of lambda squared is going to give us lambda, and so we are going to have this guy to be lambda, then square root of x squared plus y squared. So that's we are going to have lambda. Now square root of x squared plus y squared is our given function f of xy, and so we can say that the above function is a homogeneous function of degree 1. With our fourth question, we have to verify whether f of xy is a homogeneous function, and f of xy is defined to be x squared plus sine of x cosine of y. Compute f of lambda x, lambda y, and so we are going to have lambda x all squared plus sine of lambda x, then cosine of lambda y. So this is going to give us lambda squared x squared plus sine of lambda x, then cosine of lambda y. Now here, let's focus on the trig functions in here. So since these guys are trig functions, we cannot factor out lambda, right? And so we just have to leave our expression this way. So that's this function is not homogeneous. That's f of xy is not homogeneous. Thank you guys for watching. See you guys in the next video.